So in order to define tempered Frobenioids, I'm going to need to recall some notions. So I'm first going to talk about tempered coverings. And the tempered fundamental group. Okay, so I'm going to do this the first way for the tempered fundamental group. So, all right. So we're going to start. We're going to work in a category of Berkovich spaces. So work with Berkovich spaces. Okay, and then and I'm going to say that we're first going to assume that we're going to use the fact that there exists a notion of finite étale morphisms for Berkovich spaces. Okay. From this, we can make the following definition. So, a morphism of Berkovich spaces will be étale provided there exists a covering such that so the inverse image of this guy looks like a disjoint copy of Vij's, where f restricted to Vij is finite étale. Okay, so we could have some big cover here, so something of not a finite type, and then we're going to say it's étale if it on each of the pieces under an inverse image it's étale. Okay, now using that we're going to define a certain subcovering or certain étale maps to be tempered. We can define what a tempered cover is. So so F. So this is of non-Archimedean analytic spaces. Is so étale is tempered if so this is not going to be too helpful, but I'm just going to say it just for completeness. So there exists a finite étale map such that when I base change here to S prime cross S of t, so that after you base change, this is a topological. Okay. Okay, so we have this notion of a tempered cover for Berkovich spaces. So what you do is you verify that this is a site. Okay, you define for a point in the base a functor from coverings to sets. Let's call this f of x, which takes a cover. I don't know, let's go like this. Okay, and here's x, and it maps it to the fiber. So point goes to the fiber. Okay, and then finally what you do is to define pi1, Okay, so this could be a tempered cover of X. This is just going to be defined to be automorphisms of this functor. Okay, so this is kind of the abstract way of doing things. So this is the definition. Okay, and now I'm going to try and give a second way. So the second way of doing this is to take a system, a prosystem of finite Étale covers, Galois, pointed covers, let's say, then take pi 1 tempered of this non-Archimedean Berkovich space to be this inverse limit of gal S infinity over X. Okay, and so I need to explain what this means, and I'm going to do that in a second. So suppose this guy here is a finite Étale Galois cover. Okay, and we're going to define so S infinity of S. So this guy here. So this would be the universal topological cover. And then we were going to define over X. So this is like, I think I called this gal S infinity over X before. So this is going to be the set of G tilde G. I need some name here. Let's call that phi. Okay, so we have this thing, and then we have this going, let's call that pi, this going to XX. Okay, so so we have these guys, and these guys are going to be automorphisms of, let's say, S infinity over X, and then this thing's in this Galois group here, S over X. Okay, so these are pointed things again, but I'm not going to write the point, such that phi, so if I take G tilde, I apply phi. That's the same thing as if I were going to take G after applying phi. So maybe that should have been scooted over a little bit, but whatever. Okay, so this is the definition. And then I need to tell you how this is how this is a prosystem. Okay, so how is this a prosystem? So suppose we have some cover here. Let's say S2, S2. Okay, so we have maybe pi 1, pi 2, and then we have some map here, psi. Okay, so this induces some psi infinity. All right, and then we can define this map S2 infinity over X. Okay, and so remember that we had some lifted guy And then it'll map to some other dude here. And what does it need to satisfy? It needs to satisfy so that well, these two guys they both need to be intertwining with each other. So so what does it mean? It means I can either take so I can take an automorphism on S2 infinity, okay, and then I can compose with this psi infinity, and that would be the same thing as first taking psi infinity and composing with this dude, okay, and the other conditions can be very similar. It says that we're going to have this compatibility, G1 composed with psi. Okay, so this is what the system looks like, and I guess that these guys are unique. So these guys actually exist. Okay, so this gives us the pro system, and this gives us this definition of this this fundamental group. Or sorry, this system here, and so here, and so this is the limit over a filtered category of finite étale Galois covers.